You're watching a lesson on implementing DNS. So to start things off, let's just first discuss what exactly is DNS. Well, DNS stands for the Domain Name System. This is a system that is used to translate domain names, which I should tell you, DNS is also a naming convention. It's considered to be a hierarchical naming convention. It's the naming convention used on the internet. So when we say hierarchical, we're talking about when you put in www.yourfavoritecompany.com, each of those components with the dots, that's part of the hierarchy. And we're going to see as we go through this lesson how exactly that breaks down. But those are also what's known as a DNS name or a domain name. And so we use DNS to translate these domain or DNS names into IP addresses. And here's the deal. And I need to make sure we're real clear on this so that nobody is offended. But DNS is what allows us, and I want to emphasize the us, meaning I'm included in this us. It allows us to be what I call stupid humans. And what I mean by this, I'm not saying that we're all stupid. I'm not stupid, you're not stupid. But when it comes to remembering a name that represents, or let's not even say a name, an identifier for a computer, for a website, for something on a network that you want to access. As humans, it's not very easy for most of us to remember the IP address, right? And if you think of a favorite website, I mean, let's say it's trainsignal.com. Do you know the IP address to get to trainsignal.com? I mean, it's not that hard to look up. Do you want to have to just remember that? Or is it easier for you as a human to remember the name TrainSignal? Obviously, it's easier to remember the name. That's what I mean by allowing us to be stupid humans. It allows us to not have to think like a computer. It allows us to not have to remember all these numbers and actually give human-type names to our computers, to our websites, to our other network devices. Now, there are three main components when it comes to a DNS infrastructure, and those are DNS servers, okay, and these are the servers that are going to host the next component, which is the DNS database, okay, so that database is a list of names and the corresponding IP addresses, okay, so the server hosts that database for the purposes of serving, that's why they're called servers. They're going to serve the DNS clients who need to do the name resolution. Okay, so if you're sitting at a computer right now and you ask to go to a website or you ask to connect to a certain computer on your network, that machine is a DNS client because you're going to put in a name and that client is going to have to go to the server and say, hey, what's the IP address for the computer named ABC? And then it's the server who will look at the database and give an answer back and say, well, the IP address for that computer is WXYZ, W.X.Y.Z. Okay, so just to give you that general idea of what exactly we're talking about here as far as why do we even have this? That is the number one reason we have DNS. Now, DNS, I will tell you, serves a whole lot of purposes. DNS serves purposes that will go beyond the scope of what we're going to learn in this course. We've already talked briefly about how DNS is a component that is required for Active Directory domain services functionality. And it's also something that is necessary for other application functionality as well. But in this lesson, we are going to focus on the purpose of being able to be stupid humans, use names, and have DNS convert them to IP addresses for us. So real quick, what I'd like to do here is I want to just jump right over into the server and let's see DNS. Let's actually take a quick look at it. Then we're going to come back and talk about a lot of concepts that go along with this. And again, there are a lot. This is a lot to take in. Let's go take a look. So here I am on NYDC1, and this is the main, the first domain controller that we created for the globalmantics.local domain, right, at our corporate headquarters in New York. And in this case, it is significant that we are looking at this domain controller. And the reason why is because not only are we a domain controller, but as part of installing Active Directory, we also installed DNS. So if I go to my start screen, you will see that I already have a DNS utility that I can go into. And if I click on that, and then I'll expand this so we can see it, you'll see that it's showing me DNS looking at NYDC1. You'll see that I already have a whole bunch of stuff here. And we're going to talk about this stuff here, okay? We're going to talk about what we're seeing here as we go through this lesson. But one of the main things I want to point out is this forward lookup zone showing that we have globalmantics.local. This is the name of our domain, and therefore all the computers in that domain are going to be named something.globalmantics.local. Even this computer is named ny-dc-1.globalmantics.local. And if I click on globalmantics.local, I'll see that there is something called records. And again, we're going to talk about all of this in detail, but I just want to show you, should look fairly obvious. See, here we have this NYDC1, and you'll notice that it associates with 192.168.10.201. That's just showing you the database that I'm talking about, that there is a listing here. There's a record of it, so that if a client was to say, hey, I'm looking for NYDC1, this server could say, great, the IP address you're looking for is 192.168.10.201. So that's just real quick kind of showing you we already have DNS in place, and it was installed, right? Meaning if you want to think along the lines of how do I install DNS, it was installed as part of the Active Directory Domain Services installation process. Now that said, let me go ahead and close this, and let's actually close out of NYDC1. I'm going to jump into another server that I've created called NYMem1. Okay, so this is just a member server, because both NYDC1 and NYDC2, they were both created as domain controllers, and as part of the domain controller process, we made them into DNS servers. So this NYMem1, let me go ahead and jump into it real fast here. This is just a generic Windows Server 2012 computer, and nothing has been done to it other than I've given it an IP address on our network, and I have joined it to the globalmantics.local domain. But that's it. If I jump into the server manager, and of course that's where we go anytime we want to, well, pretty much anything we want to manage, but especially if we want to add a role, and in this case DNS is a role. In this server manager, I can go ahead and add roles and features, and I'm going to give this just a moment because it's still loading. Okay, it looks like it's, oh no, it's still going. So I'm going to go ahead and click on Add Roles and Features. Takes me into the Add Roles and Features wizard. We've seen this welcome screen. We know we don't need that. We're going to do a role-based installation. We're going to install on this particular server, NYMem1. You'll see that there's a role here for DNS. When you go to install that role, there's extra roles and features, so we'll say go ahead and add those features. Click Next. Click Next through the features. Click Next again. Restart if necessary. There's a warning that we always see about, hey, not going to be any warning, it's just going to restart. I say that's good. And I'll click Install. So as you can see, I just wanted to show you real quick, this role can be installed just as easily and just as quickly as any other role that we've taken a look at in this course. Now what I'm going to do is I want to jump back over to talking about some of the concepts of how this all works, because I could continue showing you stuff. I could sit here and show you about DNS. But the reality is that managing it is pretty simple. It's understanding it that's the real challenge for many people. DNS querying. A query is a request for name resolution that is directed onto a DNS server. Okay, so when I'm a client, and I'm a client saying, I'm looking for server a.globalmantics.local. Okay, I know I've moved away from that previous example where we were deep down into the subdomains, but let's go to, I'm looking for nydc1.globalmantics.local, and that request is sent to the DNS server. That's called a query. Now there's two different types of queries. There's something called iterative, and the way I like to describe what iterative means, it's if I get an iterative query, I will tell you what I know, and that's it. I will tell you just what I know, even if all I know is maybe another DNS server that you should go talk to. But that's all I'm going to tell you, nothing else. Whereas a recursive query is one where I will research the answer for you. So if you ask me who is nydc1.globalmantics.local, and I, as a DNS server, don't know that answer, but I know of other places I can go to find that answer, then I'll go find it, I'll research it, and only once I have an answer will I then respond back to you what the IP address is, or respond back to you that I can't get the IP address. Now, DNS servers can be what's called authoritative or non-authoritative. And this has a lot to do with what I was just talking about, where I'll give you an answer back, even if that answer is there is no such name or I don't know what that name is. Only an authoritative server can give the answer or an authoritative no. In other words, if I'm a DNS server and I am not authoritative over the globalmantics.local domain namespace, then I can't give you a direct answer of an IP address or a direct answer of a no. I can research it for you, but I cannot be very direct in giving you an authoritative answer. So as a non-authoritative server, I can either use my cache, meaning if I've looked it up for you before and I already know the answer from that, I can give you the answer from that cache. Or where it says I can be a forwarder, that's something we'll learn about. We'll learn about forwarding. That's where I go and send the request off to another DNS server who maybe is authoritative. And I'll tell you what, these queries can continue to be sent to other DNS servers. They can be sent to a whole series of DNS servers until they get that authoritative answer or an authoritative no, there is no such computer. Back on New York Mem1, the DNS server role has been successfully installed. I'm going to go ahead and close this. And I just want to show you, if I go up to Tools, I can now go to DNS. And here I have nymem1, right? That's the server I'm on. You'll notice I have all those same folders that I had before. But notice when I click on forward lookup zones, it's blank. Okay, we haven't actually configured any of this. Now, even though this server is not set up to serve globalmantics.local, and we'll take a look in a minute how we can actually do that, but let's look at forwarding right now. Now, the first place your eyes might go is right here where it says conditional forwarders. But before we even look there, I want to go to the properties of New York Mem1 altogether. Okay, I'm going to right click and go to the properties. And here, there's a forwarders tab. And it tells you forwarders are DNS servers that this server can use to resolve DNS queries for records that this server cannot resolve. So one way that we could set up this DNS server to actually service DNS requests would be to come in here and click on Edit, and then go ahead and add in, well, let's say 192.168.10.201, right? That's one of our DNS servers that we do have. And it's going through here and it's trying to resolve it, it's trying to figure it out, it's validating, and boom, you'll see it's validated, it's okay, and it eventually resolves to NYDC1. It knows who that is. So that would be a standard forwarder. That means generically, if a request comes into NYM1, right? In other words, if I have a client out there that's actually pointing to this server as its DNS server, and this server says, I don't have any idea what the IP address is for the computer you're looking for, you can go ahead and send that request over to NYDC1 who can service that need. So let me go ahead and I'm going to actually delete that. Okay, I don't want to have that in there, so let me delete that. Click OK. Cancel out of here. Because now let's take a look at conditional forwarding. If I right click on conditional forwarders and I say I want to create a new conditional forwarder, this is where I can now get specific and say, if I get a request for something .globalmantics.local, then I'm going to go ahead and forward that request on to 192.168.10.201. And if I click OK, there you go. Globalmantics.local is going to specifically go to that particular DNS server. Whereas I could right click and say another new conditional forwarder. What if somebody's looking for trainsignal.local? Now, I will tell you that this is completely made up hypothetical here because trainsignal.local is not something that exists in our network here that we can access. But if it was, I could go ahead and click here, put in an IP address. And so I'll just put in an imaginary IP address. All right. You'll notice that it's going to say it's attempting to resolve and it's going to validate. And this is all going to fail because I don't actually have a DNS server that is authoritative for trainsignal.local that I can access here. Okay. See, there's a timeout, an error going on. Click OK. I just want to show you that I can have these multiple conditional forwarders. So again, let me go ahead and delete these because we're going to eventually do something else here. But for right now, I wanted to show you that's how we do forwarding. So let's go back and take a look at some more concepts. The next concept I want to talk to you about is caching. So how does caching work? Well, the idea behind caching is simple. Rather than having the DNS server always have to forward its request off to some other server, always have to do the same set of iterative queries every time somebody asks for the same website that it's looked up before, we can shorten the process by having a local DNS server. Once it has done its homework and looked up the answer for you, throw it in its memory. Okay? Just throw it in its cache. And then from there, the DNS server doesn't have to go back out and research the answer the next time the same request comes in. If you want to clear the cache, right? Maybe the cache is causing problems. Maybe there was a change. There are a couple of different ways that you can do it on the server. You can do it through the actual DNS console, or you could do it through DNS command. Of course, you can always do things through PowerShell. I don't even have that listed here, but you can do it through PowerShell as well. If you want to clear the DNS client cache, then there is a command that you do called ipconfig/flush DNS. Now, what do we mean client cache? I thought we were talking about DNS servers here. Well, believe it or not, even as a client, when you make a request out to your local DNS server, once that DNS server does the homework, finds that IP address for you, not only does it cache it in case somebody else makes that same request, but you, the client, will actually hang on to that information for a certain amount of time as well, so that if you go to that same server again in the near future, you don't even go to your DNS server. You just go to your cache and say, ha, I already know the IP address for that particular server that I'm looking for. Okay, so understand that both the servers and the clients have the cache. And there is also something that I will mention to you here real quick called a caching-only server. A perfect example of a caching-only server would be nymem1. Once I set up nymem1 with that standard forwarder to point all requests out to nydc1, right? Remember we just did that a few minutes ago? I undid it, but when I first did that, I just made it a caching-only server. In other words, I don't host any zones. Okay, that's something we're going to talk about here in a minute, DNS zones. I don't host any of these zones, meaning I'm not authoritative for any DNS namespaces. So I don't have any database that's stored on my server that I can give authoritative answers to. But I am set up with a forwarder to another DNS server who can help out with these name resolution issues. And once I get the answer from that DNS server on any particular lookup, I'm going to put it in my cache. And that way, if somebody else asks me for the same name again, I will have the answer. That makes me a caching-only server. Right? I said if you're a caching-only server, that means you don't host any DNS zones. A zone is an area of the DNS namespace that a DNS server is authoritative over. Okay, so that's what the zone is. The zone is simply an area of DNS namespace. So nydc1, for instance, when I went to forward lookup zones, it had a zone for globalmantics.local because that particular server is authoritative for globalmantics.local. Now, what are some of the different zone types? We have what's called a primary zone, which means that you have a master copy of the database. You can read and write to the database. There is secondary, which means that you have a read-only copy of the database. Okay, so you're there to satisfy name lookups, but nobody can update the database on you if you are a secondary DNS server. We have something called a stub zone, which we'll take a look at in just a moment. And then we have Active Directory integrated, which is what we get when we install DNS as part of Active Directory domain services. So NYDC1 and NYDC2 have what's called Active Directory integrated zones, which is where the database is not stored on the server, it's actually stored as part of the Active Directory database and is replicated as part of the Active Directory database. We also have something called forward and reverse lookup zones. Okay, we saw that when we looked at the DNS server. A forward lookup zone means pretty much everything that we've been talking about. We take the name, right? We have the stupid human saying, I need to know the IP address for this name. So a forward lookup is being able to give the IP address for a given name. Whereas a reverse lookup is if you have the IP address, it can then reverse it back down to what's the name of that server. Not the most common thing to think about, but something that many applications will use. We also have something called dynamic updates, okay, because we need to find a way to have this DNS database get updated when new information is available or new computers appear on a network, things like that. In the old days, we used to have manual updates. You as the administrator would actually go to the DNS server and you would add an entry manually, whereas dynamic updates is where the client can actually communicate with the DNS server. And I will tell you that there are even instances where you can have DHCP, which we learned about in another lesson, communicates on behalf of the client. But either way, it's the idea of a client communicating with the DNS server to say, hey, my name is Ed, and my IP address is 10.10.10.10. And then the DNS server can go ahead and update its database. But of course, that can only happen on a DNS server that's hosting a read-write copy of the zone, which means it either has to be a primary DNS zone or an Active Directory integrated zone, which is also read-write capable. Now, I mentioned we'll talk about stub zones. DNS allows for something called delegations. A delegation is where another DNS server has been delegated the authority over a subdomain. So, the way things used to work is before we had stub zones, we go all the way back to like Windows 2000, before we had stub zones, all delegations had to be managed manually. In other words, if I am the DNS server for globalmantics.local, there may be other servers, other DNS servers that are authoritative over na.globalmantics.local, and I can create a delegation on my DNS server, globalmantics.local, saying, hey, here are the servers that are authoritative for the subdomain na.globalmantics.local. These used to be managed manually. You literally would make an entry for this delegation, and you'd update that entry if you added, let's say, a new DNS server that was also now going to be authoritative for the na.globalmantics.local domain. A stub zone is what allows for automatic propagation of these delegations to the parent DNS servers. So with a stub zone, if I create a stub zone on globalmantics.local, right, on the DNS server that's authoritative for globalmantics.local, and in that stub zone, I point to at least one, right, you have to start off manually with one DNS server that's authoritative for na.globalmantics.local. From there, as new DNS servers come into play for na.globalmantics.local, that information will be dynamically communicated up to the DNS server who's authoritative for globalmantics.local. That's how a stub zone works. Now, I mentioned that Active Directory integrated zones was something to where you basically had the database stored in Active Directory. But let's talk about some of the benefits to this. Because I will tell you that we want to wrap this whole thing up into a very simple thing. If I wanted to make a 2-minute lesson here on how to manage DNS, I'd tell you, you know what you do? You take your domain controllers and you turn them into DNS servers and you make Active Directory integrated zones and let Microsoft's operating system just do it all for you. Okay, this is the way to go. And the reason is because by having the database in Active Directory, you get to take advantage of multi-master replication. In other words, the database needs to be replicated to all your various DNS servers. Well, in the old days, we had primary and secondary. You had one primary, which was the one master copy, and all the rest of your DNS servers were secondary, read-only. Now we have what's called multi-master, and this is something that is part of Active Directory's makeup. In other words, Active Directory databases already know how to have multiple master copies. You get to take advantage of that. It's also streamlining the data replication process because instead of having your DNS replication being completely separate from your Active Directory replication, it now is just a part of it. It's built right in. You're already replicating all your Active Directory stuff. Just send the DNS information with it. And Active Directory replication is so efficient in the way that it only updates things that change, and the whole replication topology is so realistically functional. Let's take advantage of that. We also have something called secure dynamic updates on an Active Directory integrated zone. We talked about dynamic updates, but secure dynamic updates basically says a record can only be updated in this database if the client has an actual computer account in the domain. So you got to be a member of the domain in order to touch this database. Whereas in the old days, this was a very common hacking method that people would use, which would be to go ahead and shoot dynamic updates to create records on a DNS server that would change the results that would be given on a query. Now we can only do it with Active Directory integrated zones if I'm a domain member. And it's also backward compatible to the old-fashioned secondary zones. So if you have any servers that are still hanging out there that you want to keep using and they were set up as secondary zones, no problem. It will work with your Active Directory integrated zones. Now let's talk real quick about the records that you find in your DNS database, right? We looked briefly at a database and I showed you one record, right? I showed you that we were able to see NYDC1 matching up with its IP address. There are a number of different type of DNS records that are used for different purposes, and I have a subset of that list here on the screen. These are probably more of the common records that you will find. You have something called an A record, which stands for host record, or what is most simply your most basic forward lookup record, in the sense that it's just a name and an IP address. I will tell you there's a variation of this record for IPv6, and we talked about this in the IPv6 lesson, and it's called a 4A record, or it's an AAAA record, which is the host record to look up IPv6 names. There's a PTR record, which stands for pointer record, which is your reverse lookup record. This is your standard IP address back to a name record. We have an SOA record, which is start of authority, which is where you're talking about the start of authoritative when you talk about the authoritative over a zone. You have an SRV resource record, which is a service locator, meaning if you're looking for a computer that has a certain service that it can provide. Perfect example will be the reason we need to have DNS servers for Active Directory domain services is that we have to be able to have SRV resource records pointing to the domain controllers. I'm a client, I want to log in. Who can help me with that? I go to my DNS server and it says, here is the name of a domain controller that can help you log in. We have NS, which is name server record, which is the names of other DNS servers. We have MX, which stands for mail exchanger record. It's just what it sounds like when you want to send something to somebody at certaincompany.com. The mail exchanger record will point to the email server for that domain namespace. And the CNAME record is also known as the canonical name record or the alias. Perfect example of an alias. You go to www.yourfavoritecompany.com. Most companies, believe it or not, do not actually have a server named www. Now, you go to www.trainsignal.com. I don't manage our website, but I'd be willing to bet that the web server, or really it would be web servers, that host that website are not actually named, like the actual literal name of the server. If I'm on the server, I'm not named www. That's an alias. So you create a CNAME record that basically says, hey, if a request comes in for www, what they're really looking for is web server 1, right? Maybe that's the actual name of the server, web server 1. Okay, so that's what a CNAME record is. Now again, I went through these quickly, and this is just a subset of all the different types of records that are out there. These are some of the more common records that you'll see. When it comes to something called zone transfers, I already mentioned with Active Directory integrated zones, we don't need them in the sense that we replicate using Active Directory replication. We use zone transfers back in the day when we used standard zones. And I say back in the day, but we can still use standard zones even right now, our standard primary and secondary zones. The zone transfer is how you transfer information from the primary, the master read-write copy, out to the secondaries, your read-only copies. Please understand that zone transfers definitely create a security risk. This is another type of hack that is done where you basically send a transfer out to a secondary DNS server with bad information. There are two different types of zone transfers. There's something called AXFR, which is a full transfer, which is where the whole DNS database is transferred from the master out to a secondary. And this is typically only done when you first set up the secondary DNS server, or if there is some kind of major change to where everything has to be refreshed. And then more commonly, in an effort to make zone transfers more efficient, they created IXFR, which is incremental zone transfers, where only things that have changed get transferred from the master over to the read-only secondaries. All right, so let's jump back over to our server and let's just take kind of a quick look at a couple things here. Okay, so we're back here on NYMem1, and I tell you what, real quick here, I'm going to minimize the member server, and I'm going to go back into New York DC1. Didn't like my password, put that in. All right, so back here on NYDC1, I'm going to go into my start screen, jump over to DNS. I want to show you that if I jump down here to globalmantics.local, right-click, and go to its properties, you will see that I have a Zone Transfers tab. And this is where I can decide if I want to allow zone transfers from this server. Now you'll notice it's not currently allowing zone transfers. And the reason is because it's Active Directory integrated. We don't need to do zone transfers. Let's say we want NYMem1 to also be a DNS server. Now we could set it up as a caching only DNS server, right? We saw that before. But let's say we want it to be a little bit more than a caching only, right? We don't want to have to always go out there and cache that information. But I also don't want to make it an Active Directory integrated DNS server. Maybe I don't want to make it a domain controller, because that is a requirement. In order to host an Active Directory integrated zone, you have to be a domain controller. So what I'm going to do is I'm going to go ahead and say, I'm going to allow zone transfers. Now if I leave it like this, it's a little bit dangerous because I'm saying to anybody, which means a hacker could somehow put up some kind of a disguise to make this server believe that it is an appropriate DNS server that can make the request for the zone transfer, and then I'm going to transfer all my information out there. And that's not a good idea. So I could lock this down by saying only the servers listed on the name servers tab, which you'll notice when I click on the name servers tab, it'll show me NYDC1 and NYDC2 are the only ones. Or I could even get very specific and say these are the specific DNS servers that I'm willing to transfer to. Now I'm going to leave it to only the servers listed on the name servers tab. I'm going to click OK. I'm going to put away NYDC1 for a minute. I'm going to jump back over here to NYMem1. Now let's come over here to forward lookup zones. Let's create a new zone. So I'm going to right click, new zone. I get a wizard, click next. I'm going to say that I'm going to be a secondary zone. Notice some of what else we see here. I could be a primary zone if I was going to, but I can't be a primary zone for globalmantics.local, or I shouldn't be anyway, because it's going to mess things up, because I'm not going to participate with multi-master replication of Active Directory integrated, and you don't want to have that separate master out there. So I could do this, but you really can't. Or I should say, you can, I suppose, but you shouldn't. I could be a secondary, which is what we're going to do. I could be a stub zone if this was looking out for subdomains, which is not what we're doing here. And then, of course, we have this checkbox here, which is store the zone in Active Directory. Notice it says only if the DNS server is a writable domain controller. So not only do you have to be a domain controller, but you have to be a writable domain controller. So I know there's another lesson where we talk about read-only domain controllers. Read-only domain controllers cannot have Active Directory integrated zones. So what we want to do is create a secondary zone. Click Next. What is the name of this zone? And we're going to say that it is globalmantics.local. Now it says, fine. If you want to be a secondary for globalmantics.local, who's your master? Well, my master is going to be one of those Active Directory integrated DNS servers, right? It's going to be, because those are considered, even though they're multi-master, they are considered to be like a primary. So I'm going to put in 192.168.10.201. And again, if I click, it'll say it's going to try to resolve it, and it says okay, and it's going to eventually, there we go, say New York DC1. I'll click next and finish. I now have the globalmantics.local zone. And if I look at it, now you'll see it's not loaded by the DNS server. It's going to take a little while before it actually gets that information from the master. Now it's actually saying that it failed. You'll see it says correct it, and then either press F5 or refresh. If I hit F5 right now, I don't think that's going to be good enough. Yeah, I'm hitting F5, or I can click refresh to show you. There's a problem. So let's take a look back on New York DC1. If I go to the properties of this zone, under zone transfers, I said only to servers on the name server tab. If I click name servers tab, oh, look at that. The server's not there. Now, this problem may resolve itself because there may be a communication that takes place and then everything gets put in place, no problem. Or I could fix this problem by just going ahead and adding and saying, all right, as a name server that's also allowed to go ahead and communicate with this server for these zone transfers, we're going to say that nymem1.globalmantics.local, resolve that. And it says, all right, there's that IP address. Oh, and now it says the server with this site, it's not authoritative for the required zone. I will tell you that Microsoft DNS is not designed to be set up the way we're doing it right now. We're forcing a situation that it doesn't like. It wants to be Active Directory integrated. It does have support for these secondaries, and I promise you, if we wait this out, the two are going to start talking to each other. Okay, in other words, New York Mem1 is going to go ahead and be allowed to get that zone transfer. It's going to become authoritative as a result of everything that we just did. Matter of fact, I'm going to go ahead and click OK, and just out of curiosity, sometimes it happens very quickly. Let's see if we can't come back over here and refresh. Or in some cases, let's come over here and say transfer from the master. And refresh. Now see, it's still airing out. But I'm telling you, this is how you set it up, and it will work. As a matter of fact, I am so confident that this will work and that error will go away that what I'm going to do here is, again, through a little bit of the magic of video editing, I'm going to just basically wait this out. And then I'm going to go ahead and come back in a few minutes, and we're going to look at this again and see that the secondary zone has been populated. Okay, so it's been a few minutes, and what I want to do here is let's go back to our forward lookup zones. Let's click on globalmantics.local, and look at that. The error has gone away, and we now have the information. And I promise you, I have done nothing else. I just waited a certain amount of time. But there is that one catch that you have to make sure that the zone transfers are allowed. And I will tell you one other way that you might be able to alleviate this problem. I'm not necessarily a big fan of doing this, but it is a doable way of solving this problem, is enable zone transfers on New York DC1. Okay, so if you go back and on the zone, on the globalmantics.local, when we enable the zone transfers, and I'll tell you what, let's go to the properties here. Just so you can see the screen. When you allow the zone transfers in the first place, don't go to the servers on the name server tab. Say to any server. I already told you that that's a security risk, but if you only do it for the brief moment, if you just do it for a few minutes while you set up your secondary, and then once the secondary is in place, then switch to only servers listed on the name server tab, then, and let me undo this here real fast, because obviously we don't want to set up transfers from our secondary. But anyway, then you reduce the likeliness of seeing the errors that we saw here. Okay, because since we're allowing these transfers to anybody, sometimes it will go through on the first try without any issues. Although I will give you the heads up, not always. I've seen where even in the instance where it says I'll transfer to anybody, there is still a small replication hiccup in that the secondary DNS server does not get that database right away. So that's how you set up the secondary DNS server. And there's one other thing I want to show you. And that is if I come over here and I click on New York Mem1, Okay, so I click on the actual DNS server. I just want to show you right here. See where it says root hints? There's somewhere else we can see that. If I go to the properties, you'll see root hints. Remember how I talked about going out to those root DNS servers out on the internet? Well, here they are. These are all the IP addresses of the root, or that dot DNS server, out on the internet. So all those iterative queries I was showing you that start with the root DNS servers, this is how your DNS server knows how to go out there and do that. So that is, basically how you set up DNS in Windows Server 2012. Because DNS is such an important component in, pretty much all aspects of computer networking, especially when working in a Windows Server 2012 environment. Okay, but I want you to take each piece as I threw it at you and just make sure that you can kind of hold on to that piece, and little by little those pieces will all come together and you'll understand DNS. Now the other thing I want to tell you is, if you have that tingling feeling, almost like you still want to know more, you don't feel like you understand everything about DNS, well, you are absolutely correct. There is so much to DNS. I need to get you started here with just a basic implementation. But I will tell you that as you go on and learn more and more about Windows Server 2012, you're also going to learn more and more about DNS. Okay, so if you didn't caffeinate yourself at the beginning of this lesson like I had told you to, well, now might be a good time to go ahead and get yourself all ready for the next lesson. So take a break, have some coffee or whatever beverage you like, and then I'll see you in the next lesson.